Static VLANs, trunking, and VTP. Topology, this topology. Between DLS1 and DLS2, use Fast Ethernet 11 and 12. In my case, I will use Ethernet 1.1 and Ethernet 1.2. Between DLS1 and ALS1 and between DLS2 and ALS2, Fast Ethernet 7 and 8. I would use 0.1 and 0.2. 0.1 and 0.2. (11 and 12) between ALS1 and ALS2. Ethernet 1.1, Ethernet 1.2. Between DLS1 and ALS2, 9 and 10. I will use 0.3 and 1.0. 0.3 and 1.0. Okay. Prepare the switches for the lab. Use the reset.tcl script you created in lab 1. Preparing the switch to set your switches up for this lab. Then load the base.cfg into the running config with the command copy flash base.cfg running config. This is an example for DLS1. Run the reset.tcl script using the tcl shell. Create this to erase the contents on the switches. And finally copy the base.cfg file to running config to set the basic configurations. Okay, this is the script to set the basic settings. Create the base.cfg file on flash. And this script is created to erase the contents on a layer 3 switch and also set the SDM prefer on a real switch 3560. And this is the script to erase the contents on a layer 2 switch, also to set the SDM prefer on a real layer 2 switch 2960. Okay, but this is very useful, but I prefer to copy and paste these commands. These commands to erase the contents on a layer 3 switch copy and paste these commands to set the basic settings. Okay. Start all devices. DLS1. Okay, and copy these this script, these commands. Copy running config to startup config. The blank space is created to simulate the enter key. Erase the startup config. Delete the VLAN file. Delete the multiple-fs file. And set the SDM preferred, but I will remove this line because SDM is not supported by GNS3 and VIRL. Okay, blank space to simulate the enter key, reload, and apply this on the device. Okay, but this device on GNS3 by default is completely erased. It doesn't have configurations. Okay, so erase the contents is not necessary, but I will do it. I will do it anyway as an example. Okay, and here you need to enter key, two blank spaces to simulate to enter. Okay, and erase startup needs confirmation, so simulate another enter. Okay, and copy and right click to paste. Okay. Enter to confirm. The device will reload. Okay, all other devices all other devices. Okay, it's not necessary to erase contents on all other devices because they are completely erased by default in GNS3. But if you are in a real app network, you need to erase all contents. Okay, these are the basic settings that should be applied on all devices. Okay, but now take a look to the interfaces. Okay, the interfaces are different. For example, on DLS1, enable show running config from Ethernet 00 to Ethernet 03. Okay, from Ethernet 00 to Ethernet 03 to 10 to 13, Ethernet 10 to 13, to 0 to 0 to 23, and finally 30 to 33. Okay, This is the range that the domain name, disable DNS lookup, the interface range shutdown, VTP mode transparent, line console, exit timeout legend synchronous, and set the hostname. Apply this on all devices. Configure terminal, right click to paste, hostname DLS1. Okay, hostname DLS1, DLS2, configure terminal, right click, okay, the hostname DLS2, ALS1, configure terminal, right click to paste, hostname ALS1, LAS2, configure terminal, right click to paste, hostname ALS2. Configure basic switch parameters. Configure IP addresses on the management VLAN according to the diagram. VLAN 1 is the default management VLAN. With following best practice, we will use a different VLAN, in this case 99. Okay, this is the example for DLS1. Interface VLAN 99, IP address subnet mask, no shutdown. Okay, remember DLS1 is 10.199, 101, DLS2 is 102, ALS1 103, ALS2 104. Okay, DLS1, interface VLAN 99, IP address, subnet mask 24, no shutdown. Okay, the same process on all switches, but using a different IP. Ten 199. Okay, 10 199 103 24. No shutdown. ALS2. Interface VLAN 99, IP address 10 199 104 255. 0. No shutdown. Okay, the passwords are optional. Configure VTP version 2, VLANs, and trunking. VTP domain, also called VLAN management domain, consists of trunked switches that are under the same administrative responsibility, sharing the same VTP domain name. A switch can be in only one VTP domain, and VLAN database contents in the domain are globally synchronized. VLAN information is not propagated until a domain name is specified and trunks are set up between the devices. There are 3 versions of VTP available. 1, 2 are available to support normal range VLANs only, while version 3 can support normal and extended range VLANs. as well as the synchronization of other databases. Support for version 3 on the Catalyst platforms used in this lab was added to iOS version 12.2. Other iOS versions do not generally support VTP version 3. Switches operate in one of four VTP modes. The default VTP mode for 2960 and 3560 switches is server mode. However, our Lab 1 configuration changes this to transparent. Can be server, client, transparent, or off. In this lab, we will demonstrate the configuration and operation of both VTP version 2 and 3. We will do this by first configuring VTP version 2 between DLS1 and ALS1. Then configuring DLS1, DLS2, and ALS2 with VTP version 3. Look at this topology. On DLS1, verify VTP status, show VTP status, and show VTP status. Version 1 available from 1 to 3. Configuration revision 0. No domain name. Because no VLAN configurations were made, all settings except the VTP mode that was changed in Lab 1 are the defaults. This switch is capable of running 1, 2, or 3 of VTP and runs version 1 by default. All switches in the VTP domain must run the same VTP version. The VTP mode is set to transparent as a result of steps performed in Lab 1. The number of existing VLANs is the 5 built VLANs. Different switches in the Catalyst family support different numbers of local VLANs. The 3560 switch used in this lab supports a maximum of 1005 VLANs locally, while 2960 switch used in this lab supports at most 255 VLANs. Lastly, note that the configuration revision is 0. Okay, configuration revision 0. Existing VLANs 5. As you should recall from CCNA, the configuration revision number is compared amongst VTP version 1 or VTP version 2 switches, and the VLAN database from the switch with the highest revision number is adopted by all other switches in the VLAN management domain. Every time VLAN information is modified and saved in the VLAN database VLAN dot, the revision number is increased by 1 when the user exits from VLAN configuration mode. In VTP version 3, revision numbers are still used, but they no longer determine the switch whose database is going to apply to the entire domain. Instead, a single designated switch is a VTP domain called the primary server is allowed to assert its database in the entire VTP domain, even if its own revision number is lower. Other switches that are not primary servers are not allowed to assert their database even if their revision numbers are higher. Multiple switches in the VTP domain can be in VTP server mode. In VTP version 1 and version 2, any of these server switches can be used to manage all other switches in the VTP domain. In VTP version 3, a single primary server for a particular VTP domain is designated to control where changes originate from in the switched network. This enables careful management and protection of the VLAN database. configure VTP on DLS1. We will start off this lab by configuring DLS1 for VTP server mode and setting VTP domain name and VTP version 2. We will also set the VTP password, which provides some rudimentary protection against automatic VLAN database propagation. Because this password is set, VTP version 2 will not allow ALS1 to automatically learn the domain name once trunks are installed. Okay, configure all this on DLS1. Okay, configure terminal, VTP domain, switch lab, VTP version 2, VTP mode server, VTP password, Cisco 123. Now verify and show VTP status, version 2, the domain, configuration revision still 0, no VLANs created, mode server. Configure VLANs on DLS1. Let's configure the VLANs that will be required to support the network. There are two ways to create VLANs, either directly via the VLAN command or by assigning the interface to a non-existent VLAN. For now, you will create the VLANs directly on the switch. VLAN 99 to enable management interface, VLAN 999 as a parking lot VLAN for unused access ports. Suspend this VLAN to prevent ports in the VLAN from every communication with each other. The VLANs required for network operations, which are VLANs 100, 110, and 120. Suspending a VLAN deserves a special mention. Each VLAN has an operational state associated with it. It can be either active, the default state, or suspended. A suspended VLAN exists, but it does not operate. Access port assigned to a suspended VLAN drop all frames and are unable to communicate. Similar to ports put into a non-existent VLAN, putting a suspended VLAN back into the active state reinstates normal communication on ports in that VLAN. To globally suspend a VLAN, use the state suspend command in the VLAN configuration mode. This state is propagated by VTP to all other switches in the VTP domain if VTP is in use. To locally shut down a VLAN, use the shutdown command in the VLAN configuration mode. This setting is not propagated through VTP. Do not confuse the shutdown command in the VLAN configuration mode with the same command available under interface VLAN mode, which has a different and unrelated meaning. Further discussion on suspending and reactivating VLANs can be found in part 3, step 7 on this lab. Okay, create all these VLANs on DLS1. Configure terminal, VLAN 99, name, management. Enter VLAN 100, name, servers, 110, name, office, guest, (120) office, VLAN 999, name, parking lot, and suspend state suspend. VLAN 666, name, native, do not use. Finally, exit from VLAN configuration mode to make the changes. The VLANs will not appear in the VLAN database until the exit command is issued. After configuring VLANs, issue the show VTP status command and you will see that all important configuration revision number has increased based on these changes to the VLAN database. Note that the revision number you have now performing this lab may be different. And show VTP status 6. You created 6 VLANs, configuration revision 6, or use this command to only show this line. The pipe includes configuration revision to see only that line. Now configure trunking on DLS1. VTP will only propagate information over trunks. Cisco switches post dynamic trunking protocol DTP, which allows automatic negotiation of trunks. The partial output here from ALS1 shows you the default trunking mode. Okay, for example, ALS1 or ALS2. I will choose ALS1 and show IPv6, show interface. In my case, I will show the on ALS1 Ethernet 01 interface. Ethernet 01. Okay, is show interface Ethernet 01 switch port. Okay. Administrative mode dynamic auto. Negotiation of trunking on. Administrative trunking encapsulation negotiate. Switches that are interconnected and have DTP enabled can form a trunk automatically if either end is in the dynamic desirable mode or static trunk mode, on the condition that either both sides use the same VTP domain name or at least one of the switches does not yet have the VTP domain name configured. The dynamic auto mode on both ends will prevent a trunk from automatically forming. However, this is not really a valid safeguard against unintentional trunk connections, as the port can become a trunk if the other side changes to dynamic desirable or static trunk mode. As best practice, you should configure each interface into either access or trunk mode and use the switchport non-negotiate interface configuration command to disable the propagation of DTP messages. Never leave ports to operate in dynamic modes. Configure the appropriate interfaces on DLS1 to be trunks. Because DLS1 is a 3560, you must firstly specify the encapsulation protocol for the interface. Catalyst 3560 switches support ISL interswitch link and 802.1q encapsulation for trunk interfaces. In the topology, all the trunks are AO2 1Q trunks. Change the native VLAN from the default of VLAN 1 to VLAN 666. Set the interfaces to be in trunking mode only and include the switchport non-negotiate commands. The no shutdown command is needed because lab 1 configuration has all interfaces shut down. Okay, configure trunking interfaces encapsulation, native VLAN, mode trunk, non-negotiate, and enabled interface from 7 to 12. On DLS1, 7 to 12, all trunking interfaces, 6 interfaces. In my case, use this range from 01, 02, 03, and 10, 11, and 12. Configure terminal interface range, Ethernet 01 to 03, comma, Ethernet 1, 0 to 1, 2. Enter. Switch port trunk encapsulation.1q. Switch port trunk native VLAN 666. Switch port mode trunk. Switch port no negotiate. And no shutdown. By default, all VLANs are allowed on all trunks. You can explicitly control which VLANs are allowed on a trunk by using the switch port trunk allowed VLAN and VLAN ID command on the interface at each end of the trunk. There are several approaches to deciding what VLANs to allow or disallow to cross the trunk. Common practice is to disallow VLAN 1 and the parking lot VLAN. You could go a step further and disallow any ingested VLAN numbers, but you will then have to modify all the trunks should you later add a new VLAN to the network. In this lab, disallowing the parking lot VLAN from all trunks is not really necessary since VLAN has been suspended. Disallowing the VLAN can serve as an additional protection against inadvertent reactivation of this VLAN. Disallowing VLAN 1, also referred to as VLAN 1 minimization, excludes VLAN 1 from the trunk but does not restrict layer 2 management traffic such CDP, LLDP, VTP, STP, etc. from passing. Since only these two VLANs are being disallowed, the accept version of the command can be used. Okay. Switch port trunk allowed. Mark question to see the options. Okay, VLAN, mark question to see the options. Add the ID, add to the current list all VLANs except none or removed from the list. In this case, use all except one and the parking lot 999. Okay, validate and verify. And show interface Ethernet, for example, 01 switch port. Administrative mode trunk encapsulation.1q, operational mode trunk, negotiation of native 666, trunking VLANs enabled, all VLANs except 1 and 999. Configure VTP and trunking on ALS1. Next, configure VTP and trunking on ALS1. Configure ALS1 to be in VTP client mode and then configure all the appropriate trunk interfaces to use a native VLAN of 666 and to be in trunking mode only. The native VLAN number does not have to be the same across your network, but it must match between switches on a given connected trunk. Also, this allows VLANs 1 and 999. Okay, all this on ALS1. Okay, interfaces Ethernet 01 and 02. Okay, and all trunking interfaces. Okay, all the range 01, 02, 02, 03, 10, 11, 12. Configure terminal VTP mode client interface range Ethernet 01 to 03 and 10 to 12. (01 to 03 and 10 to 12). Enter. Okay, Ethernet, comma, Ethernet 10. Okay. Switch port trunk encapsulation .1q. Okay, this configuration is not placed here because this is the real lab. The ALS1 is a 2960 switch, a layer 2 switch, but I'm using on GNS3 the same switch on DLS1 and ALS1, so this command is necessary. Okay, encapsulation .1q. Switch port trunk native VLAN 666 mode trunk no negotiate trunk allowed VLAN except 1 and 999 parking lot now shut down. Then verify show interfaces trunk. Okay, and show interfaces trunk. Okay, trunking mode 01 and 02 mode on, trunking, encapsulation, native VLAN 666. Show VTP status. Show VTP status. Version running still in 1, configuration revision 0, operation mode client, no domain name. Okay, now set the VTP password on ALS1 and the VLAN database will be synchronized. However, before you can set the password, the VTP domain name must be manually configured. Okay, configure terminal, VTP domain, switch lab, uppercase, and VTP password, Cisco 123. And now check the VTP status and you will see a revision number matching that of DLS1 and that VLANs 99, 100, 110, 120, 666, and 999 are all in the local VLAN database. Show VTP status. Okay, still running on version 1. The domain is switch lab, mode client. Okay, may take a while the propagation for VLANs and VTP. Okay, show VTP status. Okay, now look at this interface VLAN 99 change state to up. Line protocol interface VLAN 99 change state to up. And now show VTP status. The version is now 2 set by the server. Domain name. The configuration revision number is 6 because there are 6 VLANs. Okay, show VLAN brief. 1, 2, 3, 4, 5, 6. Parking lot is suspended, but there are 6 VLANs propagated by VTP. Also, you can perform this show VLAN brief pipe and include the active keyword, and you will only see the active VLANs. VLAN parking lot VLAN is not included. VLAN 999 will be missing from the filtered output above because it only includes VLANs in active state, and VLAN 999 is suspended. You will also see that the configured VLANs except VLAN 1 and 999 are allowed over trunks. Show interface trunk. Okay, all except 1, 999. You will also see that the state of interface VLAN 99 has changed to up. Okay, this log message VLAN 99, and because ALS1 is a VTP client mode, local changes to the VLAN database cannot be made. Configure terminal and try to create a VLAN 199. VTP VLAN configuration not allowed when the device is in client mode. At this point, VTP version 2 is working and secured between DLS1 and ALS1. You should now be able to ping DLS2 from DLS1 and vice versa. You should now be able to ping should be ALS1 from DLS1 and vice versa. Okay, for example, on ALS1 and ping DLS1 with this IP address 99.1.1.10.1.99.1.1. Success. Park unused interfaces. On DLS1 and ALS1, place all interfaces that will not be used into the parking lot VLAN and shut them down for this lab. For this lab, the interfaces being used on all switches are Ethernet 7 through 12. Okay, in my case, I'm using 01, 02, 03, 10, 11, and 12. Okay, show running config. Ethernet 00 not in use in my case. Ethernet 13 not in use. And all range from 20 to 23, and all range from 30 to 33. Configure terminal interface Ethernet 00, Ethernet 13, Ethernet 20 to 23, and Ethernet 30 to 33. Okay, it should be interface range. Switch port node access, switch port non-negotiate, switch port access VLAN 999. Shut down the interfaces and next. The same configuration on DLS1. Configure VTP version 3 VLANs and trunking. In this part of the lab, you will configure VTP version 3 to operate across the rest of the switched network. VTP version 3 provides some significant benefits to the network administrator. The concept of a primary server was added. In VTP versions 1 and 2, all VTP server switches are equal. Any of them may add, remove, rename VLANs, and change their state. In VTP version 3, only the primary server can do this. There can be at most one primary server present in a VTP domain. The role of a primary server is a runtime state. It is not part of the configuration, rather this state is requested in privileged exit mode and is relinquished whenever another switch attempts to become the primary server or when the switch is reloaded. VTP version 3 has the ability to hide the VTP password. On a VTP version 1 or 2 switch, issuing the command show VTP password will show the password to you in plain text. VTP version 3 allows you to specify that the password be hidden in the output, preventing the password from being inadvertently or maliciously divulged. VTP version 3 can propagate information about extended range VLANs, VLANs numbered between 1006 and 4094. To support these VLANs with VTP version 2, all switches had to be in transparent mode and the VLANs had to be configured manually on a switch-by-switch basis. VTP version 3 only supports running for normal range VLANs. VTP version 3 supports propagating private VLAN information. As with extended range VLANs, the lack of private VLAN support in VTP version 2 require all switches to be in transparent mode and manual configuration at each switch. VTP version 3 added support for opaque databases. In other words, VTP version 3 can transport more than just the VLAN database between switches. The only option at this time is to share the multiple spanning tree MSTP database. VTP version 3 is backwards compatible with VTP version 2. At the boundary of the two protocols, a VTP version 3 switch will send out both version 3 and version 2 compatible messages. Version 2 messages received by a version 3 switch are discarded. Configure VTP on DLS1, DLS2, and ALS2. VTP version 3 cannot be configured unless a VTP domain name has been set. So for this step, setting the domain name is not needed on DLS1. Configure VTP version 3 using the following parameters. VTP domain switch lab for DLS2 and ALS2 only. Okay, configure VTP version 3 on all switches placed on the blue square. The DLS1 was already configured with the domain name and password. Okay. Domain switch lab on DLS2 and ALS2. DLS2 exit VTP domain switch lab. ALS2 exit VTP domain switch lab. Okay, VTP version 3 on DLS1, DLS2, and ALS2. DLS1 VTP version 3. DLS2 VTP version 3. ALS2 VTP version 3. VTP mode server on DLS2 and ALS2 only. DLS2 VTP mode server, ALS2 VTP mode server. VTP password Cisco 123 on DLS2 and ALS2. DLS2 VTP password Cisco 123 and ALS2 VTP password Cisco 123. Okay, these are the examples. Now configure trunking on DLS2 and ALS2. Okay, this is the example for DLS2, but apply this on DLS2 and ALS2. Okay, remember the range of interfaces on DLS2. Ethernet 01, 02, 03, Ethernet 10, 11, and 12. Interface range Ethernet 01, 02, Ethernet 01, 02, 03, Ethernet 10, 11, 12. Okay, this is the range for all trunking interfaces. Enter. Switch port trunk encapsulation. Trunk native VLAN 666 encapsulation .1q. Mode trunk no negotiate. Trunk allowed. all VLANs except 1,999 not shut down. Exit. Okay, the same process on ALS2. Interface range Ethernet 00, Ethernet 01 to 03, Ethernet 10 to 12. Okay, interface switch port trunk deep VLAN 666, the encapsulation .1q, the mode trunk no negotiate, trunk allowed VLAN all except 1,999. No shut down. Exit. Okay, change state to up. Verify trunking, for example, on DLS2 and show interface trunk. Okay, the trunking interfaces, the VLAN 666, trunking, encapsulation, AO2.1q, mode on DLS2, verify VTP on DLS2, show VTP status. Okay, version 3, domain name switch lab, mode server, configuration revision 0, for now is 0. Notice that the configuration revision number is 0 and the number of local VLANs is the default of 5. There has been an update because DLS1's configuration revision number was reset to 0 when the VTP version has changed. So at this point, DLS2 and ALS2 will not learn about the configured VLANs because as far as they are connected, they have the same database as DLS1. Okay, 5 VLANs, existing VLANs, show VLAN brief. Okay, the default 5 VLANs, and verify on DLS1 and show VTP status. Okay, version 3, domain, mode server, configuration revision 0. Thus was reset when the VTP version was changed. If we attempt to add a VLANs DLS1 or any of the other VTP version 3 switches, our attempt will not work and we will be told that we cannot add VLANs. Okay, on DLS1, try to create a VLAN. Configure terminal VLAN 111. VTP VLAN configuration not allowed when the device is not the primary server for the VLAN database. Now configure the primary VTP server. In a VTP version 3 domain, only the primary server can make changes to the VLAN database. Becoming the primary server requires the VTP primary privilege exit command be executed. When you issue that command, the switch checks to see if there is another switch acting as a primary server already and asks you to confirm that you want to continue. In the output from DLS2 above, note that the primary ID field equals to 000. That field will display the base MAC address of the primary server once a device is promoted into that role. Also note that a separate primary server can be configured independently for each feature support, VLAN or MST. If no feature is specified, the VLAN feature is assumed. Lastly, there is a force option which causes the switch not to check for conflicts in the identity of the primary server. If different switches in the VTP domain identify different switches as the primary server, there is a good chance there are inconsistencies in a VLAN database. Okay, on DLS2 verify show VTP status. The primary ID is 0 for now because there is no VTP primary server for now. And go to DLS1 and show VLAN brief. Okay, these are the configured VLANs. Okay, and on DLS1, VTP primary and mark question. VTP primary, mark question to see the options. The fourth option, the MST feature or VLAN. Choose VLAN to propagate VLANs. This system is becoming primary server for feature VLAN. No conflicting VTP3 devices found. Do you want to continue? Confirm, press enter. Okay, and look at this message. This switch with this base MAC address has become the primary server for the VLAN VTP feature. Verify on DLS2. DLS2. Show VTP status. Now look at this. The primary ID is the base MAC address of DLS1. The configuration revision is 1. And the number of existing VLANs now is 11. Show VLAN brief. Now you have the propagated VLANs. The promotion of DLS1 to primary increments its configuration revision number to 1. So the VLANs that were previously created on DLS1 are propagated to DLS2 and ALS2 automatically. Verify on ALS2 and show VLAN brief. VLANs propagated. Pair conjugate interfaces on DLS2 and ALS2. Okay, go to DLS2. Configure terminal interface range Ethernet 00, Ethernet 13, Ethernet 20 to 3, 2 to 3, Ethernet 30 to 33. Switchboard mode access, switchboard mode access. Okay, switchboard mode access, switchboard non-negotiate. Access VLAN 999. Shut down. Exit. The same configuration on ALS2. Configure terminal interface range Ethernet 00, Ethernet 13, Ethernet 20 to 23, Ethernet 30 to 33. Switch port mode access, switch port non-negotiate, switch port access VLAN 999, shutdown, exit. Verify VLAN management capability. DLS1 is able to create VLANs, included extended range VLANs. Note that because ILS1 is running VTP version 2 and its revision number is 6, it will ignore any of the VTP version 2 messages set to it because they have a lower revision number. When a VTP message with an equal revision number with different MD5 checksum is received, ILS1 will report an error. Here we added 7 VLANs and then removed 6 of them to push the revision number on DLS1 to 9. Okay, DLS1, show VTP status. Okay, the revision is 1. On DLS1, configure terminal VLAN 510, name test 510, exit 11, exit 12, exit 13, exit 14, exit 15, okay, VLAN 15, name 15, exit. And finally create an extended VLAN 1500, name exit. And remove from 510 to 514. Do not remove VLAN 515. No VLAN 510 to 514. Okay, and on DLS1 verify, show VLAN brief. Okay, all VLANs with 515 is present. Verify on ALS1, show VLAN brief. Now 515 was propagated using VTP version 2, on the orange square. Verify on ALS2 and show VLAN brief. Success, DLS2 and show VLAN brief. Success. At this point, you should be able to ping each switch from every other switch. Okay, from DLS1, ping DLS2, DLS3, and DLS4. Go to DLS1, ping 10, 1, 99, 101, success, 102, success, 103, success, 104, success. Change the VLAN status to deactivate ports. as already briefly discussed, the default status of VLAN 1 and user-created VLANs is the active. A VLAN can be made locally inactive by entering the global configuration command shutdown VLAN VLAN ID, where VLAN ID is the number of the VLAN to be shut down. Alternatively, the VLAN can be shut down by issuing the shutdown command while in VLAN configuration mode and then exit. Both these options are equivalent. However, only the shutdown VLAN command works while in VTP client mode. Shut down the guest VLAN 110 on ALS1. Wait a few moments, exit the configuration mode, and then issue the show VLAN brief command. The status should change to local shutdown. Okay, go to ALS1, configure terminal, shut down VLAN 110. Okay, now verify and show VLAN brief. And look at this 110 locally shut down. Okay, active with locally shut down. Reactivate all ports in ALS1 guest VLAN 110 using the no shutdown command in VLAN configuration mode. Okay, configure terminal no shutdown VLAN 110. Okay, and show VLAN brief. Okay, now active. You can put a VLAN into suspending status by using the state suspend command while in VLAN configuration mode on a VTP 2 version server, VTP version 2 server switch, or on the VTP 3 primary server switch. In a mixed VTP version network, the suspension only works network-wide if it originates from the VTP version 3 primary server. Suspending a VLAN causes all ports in that VLAN throughout the VTP domain to stop transferring data. Okay, suspend guest VLAN 110 on DLS1. Okay, go to DLS1, configure terminal VLAN 110, state, mark question to view the options, active or suspend. Use suspend, state suspend, exit, exit and verify. Show VLAN brief. Okay, is suspended, but also suspended on all other switches, for example DLS2. Show VLAN brief, suspended. Okay, for example LAS2, show VLAN brief, suspended. Reactivate VLAN 110 using the state active command in VLAN configuration mode. Go to primary server, configure terminal VLAN 110, state active, exit. Verify on DLS2, show VLAN brief. Now it's active in the only suspended VLAN is parking lot VLAN. End of the lab. Save your configurations. The equipment should be in the correct end state from this lab for 3.2 Ether channel.